Welcome back. This is the segment on input and output. Think of input and output as being from the perspective of the program. So if you're outputting something, that means that the program is sending data from the program to someplace else. That someplace else might be to a file, to an internet connection, a network connection, or it might be output to the user. And that's what we're going to demonstrate, the concept of input and output, by communicating with the user. So the user will input things into the program, and the program will output things back to the screen. First, let's look at how we would output something to the screen, and we'll do something simple, and it was in fact in the very first example that we looked at in this course, where we would output some text to the user. So the function that we're going to use in C is called printf. That stands for print formatted, and we're going to look at the call to printf that outputs hello world onto the screen. So here it is. It's this very simple function call. You have to get all of the braces, the parentheses and double quotes in the right place. Whatever appears inside of the double quotes, inside of the printf parentheses, is going to appear on the screen the way it appears inside of the double quotes, with the exception of something that starts with a backslash or a percent sign. So first of all, we'll talk about the things that start with a backslash, and these are escape characters. Remember that C is a very old language, and in the old days, controlling how things appeared on the screen was considered to be fairly difficult, and this is fairly cryptic. So we're going to use \n whenever we want what's on the screen to go to the new line. So the cursor going to the new line would require that a \n be sent to the screen. There's several escape characters that start with this backslash character, and for example, if you wanted to output a double quotes to the user, how could you do that? Because if you were ending the string with the double quotes, the compiler wouldn't know why you were putting a double quotes there, whether you wanted the double quote to go to the screen or to end to close the opening double quotes, or a single quote. There are lots more of these, and we're not going to go into them. This is a concepts class, not a C programming class. Okay, once we can output simple text from the program to the user, the next thing that we would want to do is to output the value in our variables to the user. And we're going to look at a printf statement that does that now. For example, if we had an integer variable that has 12 in it, we could put inside of the double quotes a %i. %i means that we're going to have an integer variable that corresponds to that position in the output. So this outputs this printf statement. Variable contains %i and then a comma and the name of the variable. It would output variable contains 12. So the value in the variable named variable, in this case, is output in the position where the %i appears in the printf. Here's another one where we would output the value in a double variable, so I've called this tax rate, and you might see something in this one that you don't like very much. First of all, the percent sequence for a double is %lf, and then the double, the variable is expected to be a double that matches that %lf, and this printf statement will output the tax rate is 0.070000. That might not be exactly what we would want it to do, but %lf, which really stands for for long float, and you don't know why. Remember, this is 1972 when this was created, and it can be fairly cryptic. So %lf is expecting a double variable, and it's going to print out its default accuracy. In the compiler that we're using, the default accuracy is to output 6 places past the decimal. Okay, suppose, for example, that we wanted to do something more precise than that, or more controlled with our output. We could put %.2lf, and that means in printf that we'll have 2 places of accuracy past the decimal. So let's look at our percent sequences that we know about so far that we can use in the printf statement. %i is expecting an int value or an int variable after the close double quotes comma. And %lf is expecting double values. Make sure that you type LF and not 1F. That's going to be quite different. And if you want to specify the accuracy or the places past the decimal for your double values, you can use a 0.2, or if you want 3 places of accuracy, 0.3 and so on, so that your output will appear the way that you want it to. You can put as many of these percent sequences inside of the double quotes as you want, and each of them would correspond to a value or variable after the double quotes. So in this one at the bottom of this slide, we have an int %i and a double %.2lf, and that format string is followed by an int variable and a double variable, comma separated. Let's look now at how we would do data input from our C program, and we're going to use a function for input called Scanf, and that stands for scan formatted. It looks somewhat the same as the printf statement, and there's just a few major differences. The scanf statement, first of all, is a blocking input. That means that as the program is executing, when it comes to a scanf statement, it will stop there and wait for the user to enter the data that fulfills the scanf. It wouldn't make sense for the program to keep running whether the user had entered the data or not. So this is called a blocking input. The program will stop and wait. The other thing that's different in this is that we need an ampersand before the variable name. So in this small C program snippet here that we have, we're going to ask the user to enter an integer, and then we want the value that the user entered to go into a variable called myInt. So that's the job of the scanf statement. We have the formatting string %i inside of the double quotes, and then we have the name of the variable we want the value to go in, myInt, preceded by an ampersand. I'm not going to explain right now what that ampersand is for. But when you're doing an input, you want values to go into the variable. Two things have to happen correctly. You have to have this % sign with the correct formatting string. So for an int, you need %i. And you also have to have the ampersand before the name of the variable. The other difference between a scanf and a printf is that you have to be careful that inside the double quotes of the scanf, you don't put any text. You only put the formatting string, so you put what you're expecting, the formatting string that corresponds to the data type that you're expecting the user to type. So in this case, scanf inside the double quotes, you can only have that %i and then ampersand myInt. And I'm simplifying this a little bit. This is the simplest way to use a scanf to get data into your program. So here's a complete program that does input and output using a double. Let's have a look. There's the declaration of the variable tax rate as a data type double, and then a printf statement which simply outputs to the user what the user is expected to do. So enter the tax rate appears on the screen. If we didn't have this message, the program would just stop and the user wouldn't know what to do. So this is called a prompt. We prompt the user to enter a particular value. And the next statement is the scanf, so the program stops there and waits for the user to type some number and hit enter. And when that happens, the value that the user typed goes into the variable tax rate. And then I try to encourage beginning C programmers to do this all the time when they're starting using input and output. As soon as you input a value into the program, output it back to the user right away to make sure that the program is receiving the number that you typed. So we echo back to the user the tax rate is and %.2lf and tax rate. So that will give us confidence as we write the remaining code in this program that the tax rate variable has the value in it that we expected, and this won't be a source of bugs later on in the code. Here we are in the Visual Studio, and we're going to write a simple program that will demonstrate the input and output concepts that we talked about in the slides. So I'm going to start by declaring a double variable called tax rate, and I'm not going to initialize it to anything. And now I'll print out a prompt to the user using a printf, and we'll say enter the tax rate, and let's put a \n there so it'll go to the new line, and then we'll write the input statement, which is going to be a scanf, and we will put the formatting string, and we'll use %lf and a comma outside of the double quotes, and now ampersand tax rate. So we have to use the name of the variable that was declared and spelled the same way, including the case of the letters. And now we're going to make sure that that variable has the right value in it, we will immediately print it out back on the screen. So printf, the tax rate is, and %l, let's use %.2lf, so we get 2 places of accuracy on the output, and then a \n, close the double quotes, and put the name of the variable we want to output. So this will tell us that the value in the variable is what we expect it to be, the value that the user has entered. Now, while we're here, let's do a couple more things. Let's point out that the input statement, the input formatting string, cannot have any accuracy specification on it. So when you do the output, you can specify that you want 2 places past the decimal, but you can't specify that on the way in. You can't force the user to enter something the way that you want it, but you can on the way out specify how you want it to look. So we have 2 output statements. This one doesn't output any data except for this string of text, enter the tax rate, and a carriage return. And the scanf is the input statement, and we're saying we want a double value to be entered, and we're using ampersand tax rate. And then immediately echo back the value that the user entered by saying we want the tax rate output to an accuracy of 2 places past the decimal. Okay, in the development environment, you get a little bit faster at this as you go along. You can push F7 to do the compilation. So this is the hotkey for building the project that we've just created, and we have 0 failed, so that's a good sign. And now you can press F5 to run the program. So this is a little bit faster than using the menus, and if you can memorize those, F7 to build the project, look for your syntax errors, and then F5 to run the project. So it says enter the tax rate, carriage return, and suppose we say 0.07 and hit enter. Right now the program is waiting for the scanf to finish. So this is a blocking input statement. The program waits on the scanf for the user to hit enter, and we echo back that the tax rate is 0.07. Okay, so this seems to be working. Let's demonstrate a couple of things that perhaps you might do that are wrong. For example, if you put an ampersand on the output statement, let's compile that with F7 and then run it with F5. Enter the tax rate, 0.07. The tax rate is 0. So that ampersand, if you get one there when it's not needed, you might get erroneous results. And you might like it to be caught at compile time. You might like a compile error that says you're not supposed to have an ampersand there, but that's not what will happen. And suppose you forget to put an ampersand there, on the scanf statement, and this is a very common error for beginning C programmers. Let's do an F7 to compile that. We've got one succeeded, so let's run this program now. And it says the variable tax rate is being used without being initialized. So there's a runtime error. Enter the tax rate 0.07. Enter. And it's not working. Unhandled exception. And there's an address. So this is very cryptic. And you would like it to say you forgot to put an ampersand on your input statement, but at least the debugger that we're using will point at the line of code where it thinks you made this mistake. So that's a good thing. And everyone will do that at some point. You will forget to put the ampersand there, and then get into that state where you have a runtime error. And now we've put it back the way it should be. Suppose I just put 7. The tax rate is 7.00. And so on. It's worth it to play with this a little bit. Once you get it working, try some things that don't work and see what will happen. If you put a %i here, for example, which we would use if this were an int variable as opposed to a double variable, let's see what that would do. So the compilation succeeds, and then if we push F5, enter the tax rate, 0.07, and we get the tax rate is, wow, this is a big number, minus 9.2 something. So this is obviously not what we wanted, and again, you would like it to find this error because it's fairly obvious to us that if you have a double there, you shouldn't have an I here indicating an int. Once you know that it's that's what you have to use, it's fairly obvious. But you can get some unpredictable results, and if you've made one of these errors, then it's not obvious to see what's gone wrong. So let's review the concepts now for input and output of data in a C program. Okay, let's review the concepts that we explored in this segment on input and output. Now, output of information is from the program going to the user, or it might be going to a file or onto a network connection, but the perspective is from the program, the output from the program to someplace else, and the examples we looked at, the output was going to the screen. And input is information going from the user into the program, or it might be input into the program from a file or a network connection and so on. The example we looked at was the user typing something that got input into the variables. The two functions that we used for input and output in C are printf for output and scanf for input. And the % sequences used in the scanf, there's really no choice but to memorize what these are, that there's a %i that corresponds to integer variables, and there's a %lf that corresponds to double variables, and we'll use those for both the printf and scanf functions for input and output in C. You have to be very careful not to forget the ampersand when you're doing the scanf. So scanf requires an ampersand preceding the name of the variable, and printf doesn't. And that's something that every one of us will trip over from time to time. And we also looked at the concept of a prompt. A prompt is a message that's sent to the user to tell them what to do. Usually we would prompt someone for a value that we want them to enter. So that's the concepts of input and output in C programs.